Alright, hello. So, this is your teacher again, Mr. Shkalakis, and we're going to be looking at a flowcharting problem where, given a certain formula, we have to decide what the flowchart version of it would be. Now remember, I have the actual list of what each shape means in this thing up on eCampus, so you might be checking out that as we're going through. That's from the week 2 notes. But anyways, let's go and get into this now. Alright, now, we are working with what's called a factorial. Now, factorial, if you didn't know, is where we have a number, like perhaps 4, and to get the factorial 4, which is represented by the number and an exclamation mark, we do itself times one number below it times the number below it, all the way down to 1. So if we were to do 4 factorial, it would be 24. Because 4 times 3 is 12, times 2 is 24, times 1 is still 24. Meaning we would have that be what that equals. So that's what factorial is, in case you didn't have that already. In our example here, we are working with a problem where we already have 2 that were given to us, and we have to decide which of these flowcharts could produce that output. So the best way to do that is actually just to simply take it as if we're getting the factorial of 3, and then working through the rest of it to see if we can get the result, which should be 6. 6 ought to be our goal. So let's go and try out each of these. So with the first one, starting with A. If we do the factorial of n, which is 3, we start off to set product equal to 1. Next thing we do is going to be product equals n times the product. Now n is currently at 3, product is currently at 1. 3 times 1 means that now product is going to be equal to, in fact maybe I'll just erase this, equal to 3. We go on, we set n equal to n minus 1, so n is no longer 3, it's now equal to 3 minus 1, which is 2. We ask if n is less than 1, which it is not. So since it is not, we go back to this part where we say product equals n times product. Product is currently 3, n is 2, so that means we're no longer having 3, we have 6, because we did 3 times 2. Or I guess 2 times 3 rather. So product is now 6. N becomes n minus 1. We check if n is less than 1, which it is not. It is equal to 1, so it is not less than 1. So we say no, so we go back. We set product equal to n times the product. N is 1, product is 6. So it's equal to 6 again. N equals n minus 1. Saying now to 0. N is less than 1, so we go down to the yes route and return our product, which is 6. So we know A is one of our answers. Let's go and try another one. Still with our n being 3, we're going to try out B. Now, product is equal to 1. And then we set product equal to n times itself. So that's going to be n, which is 3, times product, which is 1, to equal 3. Check if n is less than 1. It isn't, so we go back up here. We go in, we set product equal to n times the product. N is 3 and product is 3, so it's 9. Already we're in a weird area, because we know we're trying to get to 6. We've already passed 6, and it doesn't look like we're going to go any lower than where we are now. It doesn't look like we're going to go down at all. The issue with this one that's missing is this n minus 1 part. That's not in here. It's not there. So we know it isn't B, because we know that this is going to keep going on forever. Notice it keeps going so long as n is less than 1, and n is never going down. So yeah, it's never going to happen. Let's try our next one. N equals 3. So we check, is n less than 1? It is not, so we return n times factorial. So that means that's going to be a little tougher to understand. So we're returning n, which is 3, times the factorial of n, which is 3. So that means we go back up to the top here, and we check on factorial of 3. So we have in this new function call, n equals 3. Is n less than 1? It is not. So we go down to this part again, and we're going to return 3 times the factorial of 3. Now, that means we're going to check it on the same exact call as we did before. And we're going to keep doing this forever and ever. So already, let's go ahead and call that one as not the case. Just like, which really just leaves D, which we can tell because notice how this n minus 1 is in here, but not here. And notice how the n minus 1 is here, but not in here. That makes the difference for that problem. So A and D would be the answers here. And we can start solving it, as you may notice. If we do n equals 3, n is not less than 1, so we return 3 times the f of 2, which is going to give us return 2 times the f of 1, which will go on until we get to 0, and then multiply them back up for 2 times 3, equaling 6. And that's how we get that one.